Hi, folks. We're going to take a look at number 5 from lesson 6. So let's look at the question here. It says a wooden tower on the top of the hill casts a shadow of 30 meters along the side of the hill. Okay, so I think at this point, I'm actually going to start drawing my diagram so I can get a sense of what's going on. All right, so uh, we've got a hill here. Okay, I'm going to draw it as simply as possible. And we've got a wind tower. Okay, and it's creating a shadow. Make this a little taller here so we got more room in our diagram, and it's making a shadow along the side of the hill, so it doesn't tell us whether it's the right or left side. So I'll just make, whoops, there we go. So it looks like I have to reassess my hill here. Okay, so it makes a shadow along the side of the hill, and that's 30 meters long, so we have that length. All right, and it says an observer at the farthest edge of the shadow, so that would be here. So there's my observer, finds the angle of elevation to the top of the tower to be 34 degrees. All right. So this is where we may have to be a little careful, because you got to think that when you're standing on a hill, you're not sort of standing that way, right? Gravity would just pull you down. So you're still standing upright, against gravity. So you're sort of standing still in that direction. So when we're talking about the angle of elevation, we're still talking from the horizontal of the ground. Okay, so here, and let me use a different color, that means that my angle of elevation, and we'll assume we're just measuring it from the ground. Okay, this here is 34 degrees. Now, the problem is that it looks like we're going to want to work with this triangle here, because if we look a little further, it says how high is the tower, and this angle is not part of this thin triangle created by the shadow. But here's a nice little trick. If I continue going and I keep this line going all the way down, we see that I create a right angle triangle with this 34 degrees and this angle up here, all right, which is inside the triangle I'm interested in. So this angle here is just going to be, 180 minus 90, because of my 90-degree angle, minus the 34 degrees. Okay, so that's how that 34 degrees comes in handy for me. All right, so let's actually calculate that right away. 180 minus 90 minus 34, and that gives me an angle of 56. Okay, and again, what I'm looking for, if I go ahead, is the height of the tower. So I'll call X that height of the tower. Okay, but so far I just have one angle inside my triangle, and I have one side length of the triangle. That's not enough information, but luckily they tell us something else. They tell us that the slope of the hill is 13 degrees from the horizontal. Okay, so if I look at the hill here, the hill itself is 13 degrees from the horizontal. All right, so how am I going to use this to find something else? Well, let's say I go to the top of the hill. Hey, look what I could do. I could draw a horizontal line parallel to this ground at the base of the hill. And we know by the parallel line principle that if this is 13 degrees, this will also be 13 degrees. But of course, this is just going to be 90. So this angle inside the triangle is just going to be 90 plus 13. In other words, 103 degrees. And all of a sudden, I have enough information to solve my problem, because I have two angles and a side length. All right. Now, I have 30, and I also know its opposite angle, this one here, 56. So I'm going to want to use sine law, except I'm going to need to work with this side length X. I'm going to need its opposite angle, which is that little one there. But of course, once we have two angles in a triangle, we can find the third. 180 minus the 56 and minus the 103. And so that angle there is just going to be 180 minus 56 minus 103 equal to 21 degrees. All right. So we're going to see that the actual math in this question is going to be pretty straightforward. It's just applying the sine law one time. What was difficult about this problem was getting the diagram and labeling all the important parts of this diagram. So let's now go to doing the math. All right, so I'm looking for this side length x. Okay, so I'll write it in the numerator. So x over the sine of its opposite angle, which is 21. Okay, equals, and now let's use the one that we know. So side length of 30 divided by the sine of its opposite angle. So sine of 56. And so x is just going to be equal to 30 times sine 21 divided by sine of 56. And that's nice and easy to calculate. So let's do that here. 30 times sine 21 equals divided by sine 56. And here 12.968. So we'll just make that an even 13 meters. All right. So as we said, the math portion of this, the actual calculation, was quite simple. It really was about the diagram. Okay, so what was important about the diagram? First of all, the setup. Second of all, to realize that the shadow was along the side of the hill. Next is to use these angles. Angle of elevation, remember, is from the horizontal, but that wasn't enough. We needed to find a connection to one of the angles in the triangle of interest. Okay. Secondly, we used the slope of the hill and then used the parallel line principle to help us find a second angle in the triangle. Okay, so that's it for this one.